Good morning, everyone. I'm Janina Cortez, and welcome to our midterm report. I'll be doing the introduction. So, the flood data team of winter 2021 was tasked to support the need of NVCA to address key issues in the watershed, particularly in flood monitoring and forecasting. We are working closely with Mr. Mark Hartley to achieve the following deliverables, which are divided into 3 sections. For HEC-DSS, the main deliverable was to populate HEC-DSS with NVCA's raw datasets or Excel files, and this can be only attained if the team understood how HEC system function, which brings us to another deliverable, which is doing the research on HEC-DSS. For analysis, the team is slowly developing and testing Python codes to help extract the data from HEC-DSS to a platform. We've also managed to filter data such as the river, station, and data type. Currently, we are not yet able to develop codes for these desired analysis. And lastly, reporting system. This part may be recommended to be turned over to a different team. Next, to ensure that the project is running smoothly, even with a few bumps, we have assigned our team members to focus on specific tasks. As you can see, Linda, our project manager, focuses on the project management aspect, while Ankur, our team leader, liaises with the team and Mr. Mark. Other than that, he is also helping on these tasks: web application, user interface design, and of course, data extraction from HEC-DSS. Nina and Ozan are both assigned to work on populating HEC-DSS down to data filtration. Ozan is also lending a hand in the programming aspect of the project. And lastly, we have Sangeetha, who keeps an eye on our budget and assists in developing an appropriate application and design for the project. With the help of everyone, we are able to accomplish our high-level tasks. As you can see in our Gantt chart, yellow bars indicate that the tasks were done, although we were behind schedule. Our requirements gathering, which mostly deals with HEC-DSS and web application structure, began on January 18 and was done on February 25. Design phase, on the other hand, which focuses on the web application, was started last February 5 and lasted until February 26. Our development phase, the longest phase, began on February 16 and will run until April 5. And we also have the testing and closure. That's about it for the introduction. Now let's move on to Sangeetha.
Hi, I'm Sangeetha Jayachadran. Let's take a look at our project budget. The allocated hours and cost for the project is 416 hours and $20,800, which is 32 hours and $1,600 per week for the team members. This week, as a team, we have spent 32 hours, which sums to $1,600. As you can see here, out of 416 allocated hours, the team has spent 137 hours so far. This chart depicts the budget cost, this is actual cost, under each SDLC phases. Currently, the team is under development phase and the allocated budget for the same is $10,700, and the team has used $3,000 in the development phase so far. This is a visual representation of our weekly hours consumption. For this week, the team used the fully allocated hours, that is 32 hours. And this table shows the individual cost of the team members, and $6,850 is the cost spent so far as a team. I'll now pass on to Ozan to demonstrate our current status.
Thank you, Sangeetha, and hello everyone. I'm Ozan, and now I will be demonstrating our code and HEC-DSS. So, we have updated our HEC-DSS, and this is how it looks like. So, we have path A, B, C, D, E, and F in our hack DSS, and you can see their reference card here. Part A is the name of the river or creek. Part B is the name of the station. Part C is data type, and ADF here, for example, stands for average daily flow. Range is the range of the data. Interval is its interval. And descriptive noise, the descriptive no NVCA uses. And as we can see here, we have 14 stations fully populated to the hack DSS storage, and we can just tabulate one of them and demonstrate. So, for example, in Notovasaga Alistan station, we have data from 1967 to 2018. So now I will be moving to demonstrating our code which lets us export data out of HackDSS and also filter it. So here is the code. So we used Python and use PyHackDSS Python library, which is a library that lets us access to HackDSS and export data. So we have started with getting our current working directory and just accessing the NVCA float updated DSS file, which is in the same folder. Then we read that DSS file, and after that we get 3 inputs from the user. First one is river or creek name, which is path A. Second one is station name, which is path B. And third one is data type, which is path C. And after getting the data, we select that data from the hack DSS and put it in a data frame. And in this data frame, we print its units and type, which was used in the data in hack DSS. Then we print its details. Then we move on to filtering by days. We ask for a starting date and then an ending date. Then it filters our data regarding those days and gives us the filtered data and plot of the filtered data, just to demonstrate that we can access the data and create analysis or visualizations on that. So I start our demonstration. So first one is path A, asks us for a path, so we can just check here and for instance we can say Notova Saga, and for station we can enter Baxter, and for data type it is ADF, average daily flow. And when I enter, it collects the data. As we can see, it's in data frame format now. This is the first 5 entries, this is the last 5 entries, and we can see that it ranges from 1947 to 2020. And for its starting date just to give an example, we can say that 1967 February 12 to 1967 February 25th, for example. And when I enter, it filters the data and gets its values there, and we can see the plot of that data as well. So that was the basic parts of our code and how it runs in the background, whereas users will be using our web application instead of Python console. And now I will leave it up to Sangeetha again to demonstrate our web application. Thank you.
Let's take a look of the web application. Since the client wants an interface that extracts the data as per user's selection, the team has developed a web app to make it easier. This web app runs locally. What you see now is phase 1 of the web application that we are developing. The team has decided to focus on the working part of the data extraction first, putting aside the design of the application. Since the web application is working as we expected, the team will be focusing on design and customization simultaneously while adding some more features to the user selection in the coming weeks. As of now, we have developed 3 features, that is 3 drop-downs, which are river, station and data type, which list the available rivers and stations and the data types. Let's say we are selecting the river MAD and the station AMIN and the data type as annual max. If we click the Get Data button, the application will fetch the data as per the user's selection. For instance, the features that are going to be added are when the user selects the river and station, the user gets to see a text box showing this time period so that the user knows the available period of the data. After that, the user can select the required date range and get the data as per the selection. So, for the next week, adding these 2 features are going to be the team's task, simultaneously working on the design and customization of the web application. Thank you.
Hi, my name is Ankur Singh and I'm working as a team lead in this project. This project has given us an amazing opportunity to work on a niche market, which is flood data, and we got a chance to work on Hydrologic Engineering Center data storage system, which was developed by US Army Corps. But working with HECDSS was not a piece of cake, and we faced many challenges like creating a link between HECDSS to an application because of the limited resources available. But to overcome this challenge, we used Python libraries. And other challenge is the limited feature set of the HECDSS system, and we have to design our task within those limitations. Another major obstacle is performing advanced analytics in HECDSS. However, this can be tackled by using a plugin or other analytical tools to work on HECDSS data to perform advanced analytics. The next challenge was applying project management tools. Therefore, all factors must be balanced in relation to overall scope of the project. For example, the time constraint to implement the functionality required by the client. Last but not the least is to automate the process, and the solution to this is the use of programming languages for the repetitive tasks which are done manually. And if we talk about the recommendations, first is data population. We have to improve data population and data entry process. Apart from this, we have to look for ways to automate data entry and acquisition of data from online sources. Next is data filtering. For this, we should add more functional options to the app to provide better data selection to the user, and more options to filter the data according to the user needs. For example, selecting the date and the node, the center, and the river. And the third is exporting the data. We have to find a way to connect the application to analytics so that we can view the data in more visual format. The other recommendation is to create a connection to deliver filtered and selected data to an application or code so that we can perform advanced analytics on that.